Welcome to the Pendulum Lab. What we're going to be doing is investigating the behavior of what's known as a simple pendulum. Simple pendulum means that you have all mass concentrated, or most mass is concentrated toward the bottom of the so-called pendulum arm, and what's connecting it is of negligible mass, like a piece of string. So what we have here is the entire pendulum is connected up here at the top. Let me see. Right. And so we're connected up with an arm at the top, and that arm can be adjusted from right here. And so we can raise or lower the height of the pendulum simply by unscrewing here, and that way we can get different lengths. So let's come back down and let's focus on where the action really is, which is where the pendulum is located, the base of it. And so what we have is we want this pendulum. We could certainly time this in the old school way with the pendulum moving back and forth and timing its motion with a stopwatch, and you will do that. That's pretty straightforward. It just requires timing issues between you and your partner. What I want to show you is a piece of equipment which you may or may not have seen before. And so what you have here is a U-shaped arm. And this is a photo gate. And it has sensors on each side. And what this does is this is connected to a timer. Right, so it's connected to a timer. And what we'll be able to do is we'll be able to get the digital time directly from this device as the bob passes through the photo gate. And so what we need to do is we need to prepare what's known as the smart timer to tell it exactly what to do so that we can get the timing of this pendulum. That's the goal of this lab, is what conditions, what that is to say, what variables will affect the time with which a pendulum moves back and forth. Time meaning that if you pull it back and release it, the amount of time it takes to come back to its starting point. That's what we refer to as the period of a pendulum. And we can arrive at that fairly simply by setting a few controls with our smart timer. So let's do that very thing. First of all, there's the on-off switch. So we want to make sure that he's working. See, it says Pasco Scientific. And then we have some selections that we can make here on the bottom. First off, we select what kind of measurement we want to make. So here are your options in red. We're looking to find a time. So we have that ready to go, time. And then we want to select what kind of mode, that is, in what way do we want to use this smart timer to select it or come up with a time for us. And so we go through the list until we get to where it says pendulum. Makes sense, right? So what we want to do is we want to find out the time it takes the pendulum to move back and forth. And then one more button, which is the start-stop button. And what you'll notice is an asterisk which is on here, which is telling you that it's ready to go. Now notice you have a time here, and that's because the bob is actually moving through the photo gate. So we want to be careful that you or your partner was holding that back so that it's not interrupting the beam before you start. So you simply just start over again. So once you see the asterisk there, you're ready to swing the pendulum through. And so let's see what happens. 1 pass, 2 passes, 3 passes. Notice that after 3 passes through the photo gate, we have a time here. And look how precise, 2.0021. So down to 10 thousandths of a second, we're able to measure the period of this pendulum. Now, why did it take 3 passes? Well, let's come back here. On the first pass, what that does is that initiates the timer. Alright, so your smart timer is beginning. Then on the second pass, we might be thinking that that's a full period, but that's not really, only a half a period, because the way the timer is starting, and when you come back, you're going back through the opposite direction, so that's only half a period. So what has to happen is for the smart timer to recognize the full period of pendulum motion, it has to cut through a third time. So that now it's arrived back at its initial movement. And so that's why the smart timer stops. It's set to recognize 3 passes as being equivalent to the period of a pendulum. And so you're going to be doing that for different pendulum materials. So we're going to be investigating several factors. One is if we were to change out this pendulum bob with another one, keeping the length the same, how would that, say, influence the period? So that's one thing which you may have some ideas on already as to how that might influence the period. Another factor would be the length of the pendulum itself. As we change the length of the pendulum, to what degree might that affect the period? So that would be another choice. And there's also the angle itself. So you see, what we can do is we can also set the angle. So that we can see what's going on. And so by angle, we're looking at, when we pull the pendulum back, the angle away from vertical. And so we have a way to crudely do that, which is with our giant protractor. And so this protractor here, we can center it on the arm itself, and we can move the pendulum back to, well, increments of 5 degrees for certain. As you see there, 5, 10, 15, 20, and so on and so on. And so another factor that you might think could play a role is the angle with which I release my pendulum. What degree might that affect the period? So those will be the 3 variables that we'll be investigating.